In this video, I want to model a savings account using electrical components. And I want to model a savings account where I have $10,000 and I'm not going to add anything to the savings account and I'm not going to withdraw anything. It's just going to sit there and it's going to earn interest at 10%. And I chose 10% for simplicity. So in 1 year, my $10,000 should grow to $11,000. In 5 years or 60 months, it should be $16.1 thousand. And I'm in my LT Spice circuit simulator. It's free software that you can download from the internet. And LT stands for Linear Technology, the company that has this product. So let's model my savings account. I'm going to use a capacitor. So let me first select my icon. It says New Schematic. And then I can select my capacitor. And I can place that over here. And I'm going to give this capacitor a value of 1.0 farads. I click OK. And I see how I have 1.0 farads. Now do not put 1.0 F for farads because the program might interpret that as femtofarads, which is a lot smaller. So if you want to have a capacitor in farads, just put a value and don't put the F there. Now I'm going to need a current source to model interest rate. So I'm going to go to my components icon. I'm going to select this G and we're going to select OK. And I want to mirror this, so let's mirror it. And I'm going to place it over here. Now I need a ground symbol. Let me grab a ground symbol and put another ground symbol over here. Now I'm going to select the wire component. And I'm going to connect my ground to the bottom plate of the capacitor and my ground over to this current source. And let's connect the top of the capacitor over to this current source. Now what I'm doing here is I'm creating this capacitor that stores charge. It can store coulombs of charge. And every coulomb of charge that I put in this capacitor corresponds to a volt because the capacitor is 1 farad. So if I put in 2 coulombs, I'll have 2 volts. And in my model, a coulomb is going to represent $1,000. So if I have 1 volt on this capacitor, I have $1,000. In this case, I want to have $10,000. So I need to initially put 10 volts on this capacitor to model the initial $10,000 in the savings account. Now this current source is going to provide interest. It's going to provide current into this capacitor that's going to represent the amount of interest my savings account has earned. And again, I'm going to use 10% just for simplicity. So let's hook up this current source. There's some other terminals. There's a positive terminal. I'm going to connect up to the capacitor top plate. Let's connect this minus terminal to ground. Now what this does is it senses the amount of savings and it provides a current that's proportional to the amount of savings. So the more money I have in my savings, the more interest that the current source provides. Now there's a parameter in this current source. I can right click and it comes up with this value of G, which is a gain factor. So I need to set this G value to a corresponding 10%. And it turns out that that's 0.0079364. 5. And I'll click OK. And you can see that this is a multiplying or a gain factor. So it's going to take this voltage, it's going to multiply it by this small number, and that will produce a 10% interest rate. Now, how did I know how to use this particular number? Okay, there's an equation to convert interest percentage to this gain term. And if you go to the website economicsimulations.com, and at economicsimulations.com there'll be a tutorial link. Click on that, and then click on the link that explains how to model interest. And you'll see the equation that's used, and you'll also see a table down at the bottom of the page. It's a table of different interest rates versus this gain term. So let's continue with our model. I want to give this node a name. So let's select a label. So I'm going to call it savings. And now I need to deposit my initial $10,000 into the savings account, or in this case 10 volts. So I can select this SPICE directive, and I can type .IC for initial conditions, and voltage, SAVINGS, equals 110, 10. So that's how I set the initial amount in my savings account. So let's click OK, and I'm going to place that up here. So it's the initial condition, voltage of my savings node equals 10. So now I think I'm ready to run the simulation. So let's go over here and select the run icon. It shows a man running. So let's click on that. And now it wants to know some different conditions. I want to run a transient analysis, which means just the time response. I want to see how my saving grows over time. My stop time, I'm going to set for 60 seconds. Now recall that standard condition, that a second in simulator time corresponds to a month in our real world. So I'm going to simulate for 60 seconds, which is 60 months, which is 5 years. So time to start saving data. Let's start saving data all the time at 0. Maximum time step, I'm going to set it at 0.0, that's 0.001 seconds. That's just a measure of how often the program does calculations. If something's moving very quickly, it can adjust its time step smaller and not lose accuracy. So I think that that's all I need to do. I'm going to click OK. And you see it introduced this line here describing my simulation conditions. And it also gave me a graph here for my waveform. So let's click on this particular node and look at the result. And let me expand this graph so you can see it a little better. And I can click on the savings. I can call up this little box here. And let's check at time 0. At time 0, I have 10 volts, which corresponds to my $10,000. So that looks correct. So let's move over a little bit. Let's look at 12 months or 1 year. And you can see at 1 year I have 11,000, and that looks right. I'm not exactly centered on 12 seconds or 12 months, but I'm pretty close. So let's go over to 60 months or 5 years and see how much I have. Okay, I have 16.0993, which is about the rounding error. I think I set my interest rate with 5 significant decimal places. So this is very close to the 16.1, 16.0993. So looks like the simulator is simulating this quite well. And if I do nothing for my savings for 5 years, it will go from $10,000 to $16.1 thousand. Using electrical components. And I want to model a savings account where I have $10,000 and I'm not going to add anything to the savings account and I'm not going to withdraw anything. It's just going to sit there. Or 60 months, it should be $16.1 thousand. And I'm in my LT Spice circuit simulator. It's free software that you can download from the internet. And in this video, I want to model a savings account, and it's going to earn interest at 10%. And I chose 10% for simplicity. So in 1 year, my $10,000 should grow to $11,000. In 5 years, LT stands for Linear Technology, the company that has this product. So let's model my savings account. I'm going to use a capacitor. So let me first select my icon. It says